Hi, this is Lesson 5 or Chapter 5 on Access Controls, Part 1. This chapter is so long that I have divided it into 4 chunks, 4 parts, and hopefully that will help you be able to view them because there are some points I want to make that are in these videos or recorded PowerPoints that are not in the static PowerPoint and are important. So let's go. So our learning objective is to explain the role of access controls in an IT infrastructure. The key concepts are access control concepts and technologies, the formal models of access control, how identity is managed by access control, and developing and maintaining system access controls. So we want to define access control. It is the process of protecting a resource so that it is used only by those allowed to use it. It prevents unauthorized use. It puts mitigations into place to protect a resource from a threat. There are methods used to restrict and allow access to certain items such as automobiles, homes, and computers, even cell phones. Your first experience with access control might have been when you locked a sibling out of your room or used a combination lock to secure your valuables at the gym. When you purchased your first car, the keys fit only your car, so you could unlock and start your car. Just as the lock and key systems on your house or your car are access controls, so are the personal identification numbers, PIN numbers on your bank or credit card. There are 4 parts of access control. Identification, who is asking to access the asset? Authentication, can their identities be verified? Authorization, what exactly can the requester access and what can they do? And accountability, how are actions traced to an individual to ensure the person who makes data or system changes can be identified. So these are the 4 parts or components of access controls. For businesses, access controls are used to manage what employees can and cannot do. Access controls specify who users, people, or computer processes are, what users can do, which resources they can reach, and what operations they can perform. Access control systems use several technologies, including passwords, hardware tokens, biometrics, and certificates. Access can be granted to physical assets such as buildings or rooms. Now we're going to talk about policy definition and policy enforcement phases. The 4 parts of access control can be categorized into 2 phases: policy definition and policy enforcement. Policy definition, who has access and what systems or resources they can use. It's tied to the authorization phase. Policy enforcement grants or rejects requests for access based on the authorizations defined in the first phase. This is tied to identification, authentication, and accountability phases. There are 2 types of access controls. Physical controls entry into buildings, parking lots, and protected areas. And logical controls access to a computer system or network. Physical access control. Smart cards are an example. They're programmed with an ID number, used at parking lots, elevators, office doors. Shared office buildings may require an additional after-hours card. Cards control access to physical resources. On the other hand, we have logical access control, deciding which users can get into a system. For example, HR employees may be the only employees who are allowed to reach sensitive information stored on a human resources server. Monitoring what each user does on that system. For example, certain human resource employees might be allowed to view documents, but other HR employees might be able to actually edit those documents. Restraining or influencing users' behavior on that system. An example using HR again, an HR staffer who repeatedly tries to view restricted information might be denied access to the entire system. Now we need to talk about something called the security kernel. This enforces access control for computer systems. It is a central point of access control. It implements the reference monitor concept. It mediates all access requests and permits access only when the appropriate rules or conditions are met. An example is on the next slide. So here, the subject on the left over here requests access to an object over here. The security kernel, which is the database here, the access control list, intercepts the request. The security kernel refers to its rules base known as the security kernel database. So the reference monitor intercepts that, sends it to the security kernel database. It uses these rules to determine access rights. Access rights are set according to the policies the organization has defined. The kernel allows or denies access based on defined access rules. All access requests handled by the system are logged for later tracking and analysis, so they're up here in the audit log. This shows a request for access coming from the subject to a particular object, in this case a file. The reference monitor over here intercepts the access request. The access is granted according to the rules in the security kernel database. The rule base might be an access control list, a directory, or another repository of access permissions. If rules permit the access request, the reference monitor permits access and creates a log entry in the audit log. There are four central components of access control. You have your users, people who use the system that perform or processes that perform some services for other people or processes. A more general term for users is subjects. The resources. These are protected objects in the system. Resources can be accessed only by authorized subjects. Resources can be used only in authorized ways. The actions, activities that authorized users can perform on resources. And relationships, optional conditions that exist between users and resources. Relationships are permissions granted to an authorized user, such as read, write, and execute. Here's some logical access control solutions. Biometrics, for example, static would be fingerprints, iris granularity, retinal blood vessels, etc. Dynamic would be voice inflections, keyboard strokes, and signature motions. Tokens, synchronous or asynchronous, smart cards and memory cards. Passwords, you need to have stringent password controls for your users. Account lockout policies, auditing logon events, and single sign-on, the Kerberos process. And the Secure European System for applications in a multi-vendor environment, boy, that's a big one, Sesame. Authorization policies. So the first step to controlling access is to create a policy that defines authorization rules. Authorization is the process of deciding who has access to which computer and network resources. In most organizations, authorization is based on job roles, background screening, and any government regulations. These conditions or policies are decided primarily by either a group membership policy or an authority level policy, as pointed out, group membership or authority level. The most detailed authorization policy is based on each individual user. In this type, each user has specific assigned privileges. These user-assigned privileges allow administrators to define approved resource access at a very detailed level. However, maintaining user-based authentication approach is very difficult. In a group membership policy, authorization is defined by what groups users are in. Assigning group-based privileges reduces administrative workload by grouping similar users together. Microsoft Windows Server, regardless of its version, does this. In authority level policy, you need a higher level or higher degree of authority to access certain resources. For example, perhaps a senior level member of the IT group has permission to enter the room that houses servers. Lower level employees wouldn't have authority to enter that room. Our last slide in this first of four sets, we talk about methods, username, and smart card biometrics, methods and guidelines for identification, and the guidelines are actions and accounting. Identification guidelines to ensure all actions are carried out in a computer system can be associated with a specific user. Each user must have a unique identifier. It's important for each user to have a different user account from any other user. Your account policy should prohibit generic accounts and user account sharing. So this concludes part one, and the next part, part two, will go further into the various policies and methods.